Hi, this is Mr. Mitchell. Let's talk a little bit more about speed. You will hear the term speed and the term velocity oftentimes together. So what is the difference between speed and velocity? Not much. You can even see that the formulas for velocity and speed are the same, distance over time, except with velocity there is a direction. Now, when you're calculating speed, you don't necessarily have as much direction to it. I mean, you could roll a marble in the hall, down one hall, down another hall, and you could still calculate the same speed. But there is that notation for the term velocity, that you have a direction. If somebody were running on this track and they were running straight from here to here, you could calculate speed and velocity the same way. But if they were to run completely around it, velocity is really supposed to be the distance from where someone started. So you don't really want that because their distance from where somebody started would be zero. But we know in reality they have had a calculable speed all the way around. So I guess the one that you would primarily be focused on is speed, though there's really not much difference because this speed with direction is what's called velocity. Why don't we do some calculations? Now, in this class, you'll be doing some real-world applications of this formula. So as a result, I want you to kind of know a little bit about how to put things in. So I have 3 practice problems here, and they're all completely different. Here we have Mama Polar Bear ran 50 meters in 2.5 seconds to rescue her cub from the crazy penguin. So we have speed equals distance over time. In this case, it's pretty simple. You just take the distance, 50 meters, put it where distance is in the formula, and make sure you put meters in there. And you have the seconds, put it in there where time is. So 50 meters over 2.5 seconds, you just punch in the calculator, and when you do that, you will get, looks like 20, if I don't mark up everywhere, 20 meters per second. Now what I have done, you may or may not know about this video, CHSPS.2 formulas and units. Yes, go to YouTube and you just type that in. That is a reference for you. It has problems that are just exactly like this. So if you have some concerns about doing some practice problems or about seeing exactly how to do that, I do have a longer video that is that. And if you do look like you're struggling a little bit on this, let's go back to this particular video. We also have another video for this next kind of problem. Mama Polar Bear ran at 4 meters per second for 45 seconds to rescue her cub. How far did she travel? Is it asking for speed? No, it is not. It is giving you the speed and it is giving you the time. It is asking for the distance. How far did she travel? So this is an example of what's called a literal equation. A literal equation has this whole video dedicated to it. And if you see you're struggling with these, I will ask you to go to this video so you'll have a little bit more practice with it. But long story short, and you may already know this, to get the formula for distance, you take this original formula and put everything on one side except what you're looking for. Here we're trying to get distance on one side. So we are multiplying both sides by t. That's the rule. If you multiply one side by something, you multiply the other side by something as well. And the reason we multiplied it by t is because we want to cancel this t at the bottom of the fraction out with this t at the top of the fraction. Now I know I'm kind of skimming over this, but this is something that is very well detailed in this particular video, and I know some of you have seen it and have mastered it. But those of you who haven't, this is kind of the introduction to it, and you may end up needing to go back to it at a different time. So what we have now, once the t's are canceled, are t times s equals d, which is exactly what I have here. T times s equals d. So yes, you can flip the equation around and have d equals s times t. So I put the s in here, the speed, and the t in here, the time, 4.5 seconds, and that's how you ended up with the answer 180, and we are looking for the distance traveled, so that would be in meters. So sometimes you have to solve the equation for another variable that is not what you're normally looking for, and that's called a literal equation. Yes, I'd like for you to know how to do that, and we will be glad to look at that video, or hopefully you can look at that video if you see you're struggling. Here we have an example of conversions. Mama Polar Bear ran 500 yards in 2 minutes to rescue her cub. So most calculations are in meters per second. You see meters per second here, but we're not talking about meters and seconds here. We're talking about yards and minutes. So this particular reference video here talks about how to convert from yards per minute to meters per second. And we'll do one up here just because you may catch on pretty well to this. So I'm going to plug into the formula. The distance is 500 yards on top of the formula, and the time on bottom of the formula is 2 minutes, and you can see that this here. Then you have these conversion equations. You want to put times, and you want to get rid of this yards and replace it with meters. So you have to put yards diagonal to yards here. Now here you can just Google how many meters are in a yard, and or how many yards are in a meter. So you have 1 meter, and this is what I found out from the internet, equals 1.09 yards. Then that will cancel out the yards, and you have converted yards to meters. But in this particular one, you also had to convert minutes to seconds. So you do the same exact thing. You can then multiply it by however many seconds are in a minute, which this you probably know. There are 60 seconds in 1 minute. So that means you can cancel out the minutes. And the only thing you are left with as far as units is meters per second. So you multiply the entire top row, 500 times 1 times 1, and that equals 500. That's a pretty easy one. And then that goes over everything in the bottom row times itself. So I happen to have done this one already, and I know that it is 3.82 seconds because everything else has canceled out. That's 2 times 1.09 times 60 right there. And you know, that doesn't look right. So 60 times 1, that should be something else. So why don't I go ahead and calculate it? But you can see what is going on here. You have to have a conversion, and I'm pulling up my calculator elsewhere. 2 times 1.09 times 60 equals, and that is 130.8. I'm glad I looked that up. So that didn't look right. But now I know why it didn't look right, because it was not right. So I have 500 over 130.8 seconds. And then from there, it's just a matter of typing in the calculator. 500 divided by 130.8, and that is going to equal 3.82. And of course, we have to have meters per second. And that's how you do that. There's only one other thing I want to include in this one. Can you calculate speed from a distance time graph? Look at this particular distance time graph. Someone is walking or running, and they are moving faster. They are accelerating. You can tell that because of the rise in the graph. So if you were to just look at a graph, you can take any given point on the line. For example, this point is after 3 seconds. The person has traveled 10 meters. So you would just simply have 10 meters over 3 seconds. And then you can just punch that into the calculator, which would be 3 point something something. Why don't we try it at 5 seconds? At 5 seconds, they have traveled 25 meters. So 25 divided by 5 is going to be 5. So they are going at a different rate at a different point in the line. And that will be the case on every one of these unless you have a perfectly straight diagonal line. So overall, at 10 seconds, they have traveled 100 meters. So after 100 meters, divided by 10 is going to end up being 10 meters per second. So you can see at 10 meters per second, they have actually total traveled faster than they had in all these, because these were different points in the line that they were traveling a little bit slower. So I hope this has been an informative video about speed.